Hello friends, welcome back to our channel. So in today's session we'll see one more concept in discrete mathematics, that is solving of the first order homogeneous recurrence relation. So in our previous session we have seen what is a recurrence relation and what are the different types of recurrence relations. So in that we have seen the homogeneous, non-homogeneous, linear, non-linear, as well as the order by order, that means the first order, second order and the higher order. So in this session, without delay, we'll start the concept, that is how to solve the first order homogeneous recurrence relation. First order homogeneous recurrence relation. So once again we'll have a quick recall what exactly means the first order as well as the homogeneous. So recurrence relation, coming to the recurrence relation, so based upon the current term, in order to find the current term in a sequence, so we will be using some recursive manner of the previous terms. So that we call it as a recurrence relation. So finding out of a term in a sequence from the previous terms. And if the current term depends completely upon the previous terms only, then we call it as a homogeneous recurrence relations. And coming to the first order recurrence relation, so that means the current term will be depending on exactly the one previous term. So we have seen the thing. So how can we find out the problem which is a first order or not? That means we need to find out the order by differencing the higher subscript with a lower subscript. Okay, so coming to this first order, it will be in this way: an is equal to, okay, so similarly like c1 into a power n minus 1, okay, c1 into a power n minus 1, because so here the current term, so this is the current term, okay, current term, so that will be depending exactly on the previous term. This is a previous term, and where c is a constant. C is a constant. So the order, what is the order? Is the higher subscript is n minus lower subscript n minus 1. So that becomes n minus n plus 1. So the order is 1. So this is a first order recurrence relation. And one more thing, here the condition is very important, where n is greater than or equal to 1. So n is greater than or equal to 1. Okay, so hope you understood this one. Now the general solution, I'll write here, general solution for any kind of problem regarding this first order homogeneous recurrence relation. The general solution is an is equal to c power n into a naught. So this we have to remember. So this is for first order recurrence relation. For first order recurrence relation, for given problem, we need to find this format. So here we will be having a naught, the initial condition, we will be having the constant. So we need to find out these things. Okay, we need to find out these things and we have to get the solution in this way for first order recurrence relation. Hope you got it. Now let us solve a few examples on the first order recurrence relation. So let us solve this problem, first one. So 4an minus 5an minus 1 is equal to 0 for n greater than or equal to 1, and the initial condition is given a not equal to 1. So for this particular equation, we need to solve this particular recurrence relation. Okay, now first we have to find out the order. How can we find out the order? So here today's concept is first order homogeneous recurrence relation, so obviously we can say this is an first order. But if you are not having this one, if you are giving only this problem, how can you find the order? right? So what is that order? In order to find the order, the difference between highest subscript and lowest subscript. So highest subscript is n and lowest subscript is n minus 1, obviously, which is nothing but 1. So this is a first order recurrence relation. And one more thing we have to check, that is n should be greater than or equal to 1. If n is greater than or equal to any other number, first we have to change that relation to the first order recurrence relation. Okay, now, so you can see, you can write this as 4an is equal to 5an minus 1, and an is equal to 5 by 4 into an minus 1. So this is in a similar way that an is equal to some constant into an minus 1. So here the c is equal to, we can directly write it as 5 by 4. The constant is a 5 by 4. Now the solution is not this one, solution is this one. Solution is an is equal to c power n into a naught. So we are having the initial condition a naught. So this will becomes 5 by 4 whole power n into 1, which means an is equal to 5 by 4 whole power n. So this is the general solution for this first order recurrence relation. Okay, so hope you understood. So like that, we have to find out the solution of this formula. Okay, not this one. So we can make the relation in this formula to find out the c, but the general solution for any first order recurrence relation will be this one. An is equal to c power n dot a naught. So sometimes we'll be giving some a1 or a2 values. From that we have to get the a0 value and substitute in this particular solution. So let us see one more example in such a manner. So let us solve the second example. So here an minus 7an minus 1 is equal to 0 for n greater than or equal to 1. So this is a first order recurrence relation. We need not change anything because here we are having n greater than or equal to 1. And the initial condition was not given, but a2 value has been given. a2, that means a third term. a2 means third term. So but we need an initial condition a0 for first order recurrence. So let us find out. So from this, what we can write, an is equal to 7 into an minus 1. So this implies c is equal to 7 because an is equal to c into an minus 1, because this is a first order. So the current term only depends upon the exactly previous one term. So if n is a current term, the previous term will be n minus 1. So this will be depending on this one, n minus 1. So c is 7. Now we got a 7. Now what is the formula, general formula? An is equal to c power n a naught. So here from this one, okay, let us take n is equal to 2 because we are having a2. So a2 is equal to 7 into a1. Okay, hope you understood. N is equal to 2. From this particular equation, we are substituting n is equal to 2. So a2 is equal to 7 into a1. So a2 value is 98. 98 is equal to 7 into a1. Then becomes a1 is equal to how much? 14. So a1 becomes 14. Is it sufficient? So no, it is not sufficient because we required a0 value. Now let us substitute n is equal to 1. N is equal to 1. So a1 is equal to 7 into a0. 7 into a0. So here we are having a a1 value. So 14 is equal to 7 into a0. That becomes a0 equal to 2. a0 equal to 2. Is it sufficient? Yes. So in order to find the general solution, this one will be the sufficient. So the general solution for given recurrence relation, okay, is an is equal to c. What is the c value? 7 power n into a0. a0 is 2. So this is the final solution for given first order homogeneous recurrence relation. So here we have not given the initial condition. So here we have given some A2 value. With the help of A2 we need to find the A0 because the general solution is containing A0 value. So we are substituting n value as 2 so that we are getting A1 value, and if we are substituting n is equal to 1, we will be getting A0 value. So obviously we will be getting the general solution. So hope you understood this. So let us solve one more example. So let us solve the third one, that is an plus 1 is equal to 4an. Okay, so first let us check whether it is a first order recurrence relation or not. So this is not a first order because n greater than or equal to 0. So always the first order recurrence relation, the n value will be greater than or equal to 1. So first we need to convert it. So in order to convert it, replace n is equal to n minus 1. So substitute n is equal to n minus 1. So n minus 1 plus 1 is equal to 4 n minus 1, and here n minus 1 greater than or equal to 0. So this becomes an is equal to 4 an minus 1, and this becomes greater than or equal to 1. So this will be in the first order recurrence relation. Now we have to solve this one with the initial condition a not equal to 3. Okay, so initially whatever the thing we got in this problem is not in a first order recurrence relation. First we need to make that in a first order recurrence relation, then we have to solve it. So in order to make it as a first order recurrence relation, so we are substituting n with n minus 1. So here we will be substituting n with n minus 1 so that we will be getting in a first order recurrence relation. Now the remaining process is same. So from this part we know c is equal to 4 because an and an minus 1, this is a c. So from this formula, so we will be getting c is equal to 4. Now a naught, we are having a naught. So the general solution, we can directly get the general solution here, right? So general solution an is equal to c power n. So 4 power n into a naught. So which is nothing but a 3. So this is a general solution for given recurrence relation. Hope you understood this kind of problems. First we have to check whether the given recurrence relation is in a first order or not. So this is not in a first order. So even though we are using only one term, okay, one previous term, so obviously if it is a n plus 1, the previous term will be n term only. So even though it depends upon the previous term, but the n value is greater than or equal to 0 here. So we need to convert it because it always the first order recurrence relation will be having n value greater than or equal to 1. So like that we can solve this, and we'll solve one more example and we'll close. Now let us solve the next example. So 3an plus 1 minus 4an is equal to 0 for n greater than or equal to 0, and the initial condition given is a1 is equal to 5, the initial values. So here you can see this is not in a first order recurrence relation, so n greater than 0. Now you can substitute n with n minus 1. So 3a n minus 1 plus 1 minus 4 a n minus 1 equal to 0, and n minus 1 greater than or equal to 0. So this becomes 3an minus 4a n minus 1 equal to 0, and n greater than or equal to 1, and a1 value is 5. So we have converted the given problem to the first order recurrence relation. Now we have to solve it. So from this we can say 3an is equal to 4an minus 1. An is equal to 4 by 3 into an minus 1. So from this we can decide c is equal to 4 by 3. C is equal to 4 by 3, constant. What about a naught? So we are not having a naught, we are having a1. So substitute n with 1, this one, right? So a1 is equal to 4 by 3 into a naught. So here we know a1. What is a1? 5. So 5 is equal to 4 by 3 into a naught. Now a naught value, what is a naught value? It's a 15 by 4 into 15 by 4. So this is the A naught value. So from this we can find the general solution. General solution for this one is an is equal to c. What is the c? 4 by 3 power n into a naught, 15 by 4. So this will be the general solution for a given first order recurrence relation. Okay, so the first order recurrence relation is very simple. Okay, so that means it will be having only one root. So this is, we can call it as a root. Okay, so this we can call it as a root. It's a constant. It's a constant, right? So hope you understood this one. First order homogeneous recurrence relation. So whenever an equation or any relation was given, first we have to find out the order of that particular recurrence relation, and we have to follow the procedure, because coming to the second order and the third order, the procedure will be somewhat different. Okay, even for non-homogeneous recurrence relations also. So this is all homogeneous, because here you can observe for any recurrence relation so far we have solved, there are no powers, there are no multiples. Okay, only linear terms will be there, the combination of linear terms without powers as well as without multiples. So if the recurrence relation is having the powers and the multiples, then we will be calling it as a non-linear, and there is no other constant. It depends upon any no other constant, only depends upon the previous terms only. So that's also homogeneous. If we are having the equation with any other constants, then we can say it as a non-homogeneous recurrence relations. So we'll solve all the problems, all the cases, so in our coming sessions. Okay, so hope you understood this one, and if you feel any difficulty regarding this one, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. And if you really enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.